Hello everyone, today in this video I will solve some chapter 9 exercise questions, that is 9.1, 9.2, 9.3 and 9.4. Let's move on to our first question, that is 9.1, and the question is: a steel wire of length 4.7 meter and cross-sectional area 3 into 10 to the power minus 5 meter square stressed by a small amount as a copper wire of length 3.5 meter and cross-sectional area of 4 into 10 to the power minus 5 meter square under a given load. What is the ratio of the Young's modulus of steel to that of copper? Firstly, we will write what is given to us by the question. Length of steel wire equals to 4.7 meter and area of cross sectional of steel wire equals to 3 into 10 to the power minus 5 meter square. Also, length of copper wire equals to 3.5 meter and area of cross sectional of copper wire equals to 4 into 10 to the power minus 5 meter square. According to question, we have given that force and elongation, that is delta L, is constant in both the wires. First wire of steel, second is of copper. In both the cases, these are constant. So it is up to you to use it in a question or not. As we know that the value of Young modulus of any material equals to force into length by area into elongation. So the first equation we get that Young's modulus of steel equals to force into 4.7 meter by 3 into 10 to the power minus 5 meter square into delta L, and for copper, that is force into 3.5 meter by 4 into 10 to the power minus 5 meter square into delta L. Now according to question, we have to find the ratio of Young's modulus of steel to the Young's modulus of copper. Now we can write it as Young's modulus of steel by Young's modulus of copper equals to 4.7 into 4 by 3.5 into 3. All the stuff that can be cut it down is cutted, and we get a final answer, that is 1.79. And also we can write it as 1.8, and this is the final answer of this question. Now move on to our second question, that is 9.2, and the question is from figure 9.11 shows the strain stress curve for a given material. What are A, Young's modulus, and B, approximate yield strength for this material? Here is a graph for the material where you can easily see all the details that is required to solve these questions. Now, firstly we have to find the Young's modulus. As we know that Young's modulus equals to stress by strain. So according to graph, we have given the value of stress equals to 150 into 10 to the power 6 Newton per meter square. Why we take this value? Because you can take every value, you will get a same answer. So I take the middle one. So strain equals to 0.004, and now use this in the formula. We get y equals to 150 into 10 to the power 6 Newton per meter square by 0.004, and we get a final answer, that is 75 into 10 to the power 9 Newton per meter square. Also we can write it as 7.5 into 10 to the power 10 Newton per meter square, and that is the answer for first part of second question. Now B, we have to find the yield strength. If you don't know what is yield strength, you can check out my previous videos, or I will tell you in short. Maximum stress object can sustain after that it regain its original state. And here for the material we have given, that is 300 into 10 to the power 6 Newton per meter square, and in the graph you can see this easily that the highest stress point or the value is 300 into 10 to the power 6 Newton per meter square, and that is the answer. Now move on to our third question, that is a stress strain curve for material A and B are shown in figure 9.12, and here is two diagrams or graph for two materials. Which of the material has a greater Young's modulus value and which of two is the stronger material? Now we have to find both the questions answers. Now here also we given the material A or different body or different material and material B of different. Answer of first is material A has a greater Young's modulus value because the steel, material A has the value of stress greater than that of material B. So Young's modulus is directly proportional to strain, and that is the answer for first question. And second, which of two is a stronger material? If we have the Young's modulus value high, also the stronger will be it. So material A is a stronger material among both of them. And that is the answer for this question. Now move on to our last question, that is 9.4, and the question A, read the following two statements below carefully and state with reason if it is true or false. A Young's modulus of rubber is greater than that of steel. B. The stretching of a coil is determined by its shear modulus. First, the answer of first is false. Why false? Because the Young's modulus value of steel is more than that of rubber, because Young's modulus is directly proportional to stress, so steel can take more stress value than that of rubber. And B is true, because when two opposite force acting on a coil, there will the use of shear modulus will happens, or we have to use it to take out the value. At last, thanks for watching. Like and comment for more videos. Thank you.